All right, let's dive into one of the most foundational topics in cloud computing. We're going to talk about how you can build your very own secure private space inside the huge public world of Amazon Web Services. Basically, we're going to design a fortress in the cloud. Let's get right into it. So here's the big question, right? You've got this amazing application, but you're putting it out there in a shared public environment. How in the world do you carve out your own little corner that's completely yours, totally secure, and walled off from everybody else? How do you build that fortress? Well, the answer, and honestly, the hero of our story today, is the AWS Virtual Private Cloud, or VPC. Just think of it like your own private data center that happens to live securely inside of AWS. This is the foundation, the very walls of the fortress we're about to build. Okay, so before we can even think about building walls, we need to survey the land, right? We have to draw the property lines for our fortress. And in the cloud, that means planning out our IP address space.
This is done with something called a CIDR block. Now, I know this might look a little technical, but the idea is actually super simple. It's like claiming your plot of land. Choosing a CIDR block like 10.0.0.0/16 gives you, get this, over 65,000 IP addresses. That is plenty of room to build and grow. Getting this right at the very beginning is so important because you really don't want to run out of space later on.
All right, we've claimed our land. Now what? How do we actually let friendly visitors in and out? It's time to build the main entrance and the public-facing areas of our fortress. And the very first piece of this puzzle is the Internet Gateway. This is, quite literally, the main gate to your VPC. By attaching this one thing, you create a pathway for communication between your private network and the public internet. No gateway, no connection. It is that simple. Now, inside our fortress walls, we don't just have one big open area. That would be messy. Instead, we have different zones, and they're called subnets. They really come in two main flavors. You've got your public-facing lobbies for visitors, and then you have your secure internal back rooms for all the private stuff. Let's see what makes them different. What's so great about this slide is how clearly it lays it all out. A subnet becomes public if its traffic has a direct route to that internet gateway we just talked about. This is where you put stuff like your web server. But a private subnet? Nope. It has no direct path out to the internet. It's for your secure backend things like your databases that should never, ever be exposed. They use a totally different kind of gate called a NAT gateway, which we'll get to in a minute. So we have public zones and we have private zones. But how does the traffic actually know where to go? How do we enforce the rules of the road and make sure data packets don't get lost or, wander into the wrong room? Well, that is the job of the route table. The best way to think about it is as the GPS or the internal road signs for your entire fortress. Every single subnet gets a route table that basically says, hey, if traffic is trying to get to the internet, send it over to the internet gateway. If it's going to another part of our fortress, send it over here. It gives you incredibly precise control over the flow of traffic. And here's that other gateway we mentioned, the NAT gateway. This thing is so clever. Here's what it does. It lets your secure servers in the private subnet reach out to the internet, to download security patches or updates, but it prevents anyone from the internet from starting a connection back in. It's a secure one-way door, absolutely essential. Okay, so we've got all of our building blocks, right? We have the walls, the gates, the different rooms, the road signs. Now let's put it all together and see how it works in a classic real-world example, a 3-tier web application. Okay, so picture it. A user types your website into their browser and hits enter. That request zips across the internet, arrives at your VPC's front door, the internet gateway, and is immediately sent to your public subnet. And sitting there, in that public lobby, is a load balancer, acting like a traffic cop or a receptionist, ready to direct the request. Now that load balancer doesn't actually do the work itself. Instead, it forwards the request deeper into the fortress, into a private subnet. This is the app tier. This is where your application servers live, the brains of the whole operation, and they get to work processing the user's request. So a lot of the time, the application needs data to do its job, so it makes a request to the most secure room in our entire fortress, the data tier. This is another, even more locked-down private subnet that holds your database. And this just perfectly shows that principle of layered security. You keep the crown jewels in the deepest, most protected part of the castle. So the database sends the information back to the application server, which puts together the response. That response travels back out through the load balancer, then out the main gate, the internet gateway, and all the way back across the internet to the user's browser. The whole secure round-trip journey is complete. Now, that blueprint sounds amazing in theory, but in the real world, it is so easy to make a few critical mistakes, especially when you're just starting out. So let's talk about what to avoid. We're going to focus on 3 of the most common and honestly most damaging mistakes people make when they're designing their first VPC. If you can get these right, you're going to save yourself a world of pain down the road. First up, poor IP planning. You choose a CIDR block that's too small, and eventually you will run out of addresses and have to tear everything down and start over. Second, ignoring multi-AZ for high availability. This just means putting all your eggs in one basket. If that one data center has a problem, your whole app goes down. And third, oh man, this is the biggest security sin of all, putting your database in a public subnet. That's like putting your safe on the front lawn with the door open. Just don't do it. So how do we dodge all those mistakes and get started on the right foot? Well, here is a simple, really solid blueprint that you can use for most small to medium-sized applications. Look at how this plan directly fixes all those mistakes. We start with a big 16 CIDR block, tons of room to grow. We create 2 public and 2 private subnets, and this is the key, we spread them across 2 different availability zones for high availability. The database is tucked away safely in a private subnet, and we have a NAT gateway for any secure outbound connections it needs to make. This is a solid, resilient foundation to build on. And really, that's the main takeaway here. The goal isn't for you to become a networking genius overnight. It's about comprehension. You now have the conceptual blueprint. You understand how to think about building a secure, scalable, and resilient network in the cloud, and that is a huge deal. So you have the architectural plans for your secure fortress. The walls are defined, the gates are in place, all the secure zones are established. The only question left is, what amazing thing are you going to build inside it?